and how to do it. So there's a few ways that I'm going to approach in this video. By no means are they exhaustive or every feature. Sometimes I get comments of people who think to expect that if I go over something I have to go through every single feature, so I'm going to be clear now. No, this is a way to get your feet wet and how to get moving with it. Let's create a new part. You are given the option to create a new sheet metal part, but I'm creating a new part for this example. I'm going to create a sketch, and I can even go with something like a polygon, right? I think hexagons are pretty cool shapes. So we're going to apply that. Let's go with a horizontal, and I'll give this a dimension of something like 4 inches. Let's deactivate and extrude. Maybe we could go to a depth of something like 7 inches. And now I can choose a convert to sheet metal option. Of course, we have to save in order to do so, so I'll click the save button here. And now I should be able to convert to sheet metal. And yes, we'll change monitors temporarily here. So we want to define a tab, right? And that's the unmoving face when everything is unbent. Or you could also think of it as the main face that everything is bent from. So I'll select this as my tab. You can choose whatever you want. And for bends, I can simply choose something like this face. And if I choose that face only, when I say face, I mean edge, right? I choose an edge to bend from. I say OK. And everything else that isn't connected by a bend is omitted. And I can choose my flat pattern here. What else is interesting is I can edit my sheet metal part by going to the conversion, right-clicking, and I can add more bends, right? I can bend here and here and here, and perhaps I can go all the way around. Oops, there we go. And define a hollow sheet metal part, to which I can also extract the flat pattern, and as you can see, that's how we would flatten it out. I can also edit my conversion, but I have to be in the non-flat pattern view, of course. We'll edit, and I can add in another bend, perhaps here, and that creates a top of my part. Of course, I think that that had errored out the way that I defined that, so no surprise there. Let me edit my conversion again, and this time let me clear all and do this right. Perhaps I can redefine also a new way of bending this out. Right, so I can define bends at every part of the base, and when I flatten that out, we have a radically different flat pattern. Let me go in and also, this time not in a way to promote an error, define a bend here. And now I have a hollow figure with a top on it. And I can extract a flat pattern and see exactly the sequence that I would need to create this. I don't know if this is easily created, making a closed sheet metal figure. That might be humanly possible. Now, let me, is there anything else I want to cover? Yes, why don't I edit my conversion and just say I can always edit my thickness right here. This can also be tied to global variables, to which I can edit in here, right? So there would be a standard thickness. So if I want to say 16 gauge stainless, 0.0625 is the typical there, and you can see my thickness is updated. You can also just straight type a thickness in here. You can also adjust your global radius, right? So your radius is the highlighted part here, and that should be a variable equation, right? So there's our result. So I usually, for my global radius, just type in a new value. If I go to something that would demonstrate this a lot, maybe something large like 1 inch, and say OK, you can see how we automatically deal with making this into a sheet metal part. And if I unbend this, whoops, I mean, if I want to extract my flat pattern, there we go, right? Flat pattern and unbend are a little bit different. Maybe I should go through that in this video too. Okay, so let's go with another option here for sheet metal. I'm going to close this. Maybe we can save. And I'm going to grab this create sheet metal parts that you can unbend option. So this opens up Alibre in the sheet metal interface. And I can create a tab as before. Alright, so if I activate my sketch, say on the XY plane, and do something like a polygon, and whoops, apply, we're going to go horizontal, we're going to add a dimension here of 2 inches, maybe something a bit larger, 10 inches, really large. I'm going to deactivate, and then I click my tab, and it automatically populates my tab in here. Right, so I've created this nice tab. Now I can add in a flange, and a flange is simply a bend off of an edge. So I can start populating my flange off of a various number of edges, or just one if I prefer. I can set a length. You can also do these one at a time if you want these to go to different depths or something. And you can keep on just defining edges as you go, and I can adjust my angle here at 45, so I can almost make this, you know, hexagon, almost like flower petal type of shape. Here I've selected the wrong edge, and it's gone in a way that I don't wish to go. So there's an interesting little sheet metal aspect that I think is pretty cool, right? So we'll close that, and as always we can extract our flat pattern. Next, I may want to do something different than using the tab and flange approach. There is a axis panel on my water heater. Maybe I should model something similar to that, as it requires kind of a different way of doing things than we've done here. So let's actually, I'll save this so you can download it from CAD. And we'll close this to create yet another sheet metal part. So in this sheet metal part, let's activate a 2D sketch, and I'm going to sketch out a profile that I would have on an axis panel. In my case, an access panel, kind of like what I have on my water heater. So I'll add a horizontal constraint here and here. We'll add a dimension, something like this. I want to go with maybe a 3-inch radius. I don't want these to end quite on vertical, so I'm going to come up and make this something like a 1/4 inch off. That looks good. And then I'll add an arc, right? And we'll actually move this guy way down here and give a radius of, oh, let's go with 16 inches. That kind of looks like an axis panel here. I want to add a vertical constraint here to here, and that should constrain me so that I only have this endpoint to worry about. So we'll say my axis panel ends right about there, and I'll give that something like 6 inches. We'll do the same thing here, and I can share this endpoint so that the arcs are going to be the same. We'll add in a horizontal relation here and there, and we should be good. Next, it's interesting that a contour needs a linear segment as a flange to unfold on. So I'm going to add a line here. Right, we have a tangent relation, and I'm going to give this an overall length of, say, 10/1000ths of an inch, right? So there's 10/1000ths of an inch. You That is so small you actually would need a it's really hard to measure. In other words, this is way beyond what the tolerances of a sheet metal part would be. So that linear segment should have probably no impact on anything that we'd be dealing with here. So I'm going to toggle my sketch view on, and we'll go back to sheet metal where I'm going to add in a contour. And a contour allows me to select a sketch here, and we'll go to a depth of something like 6 inches. In fact, let's go mid-plane, 6 inches, 3 in every direction. That gives you some easy mirror opportunities if you wish. You always can adjust your K-factor. It looks good to me though. And bam. So it looks like this contour didn't work. And I think what I'm missing is sketch fillets. So let's grab a sketch fillet here and go from here to here. 1/2 inch is a fine dimension for a sketch fillet. And likewise, we've lost a little bit of constraints as we've defined that, so we'll simply add in a horizontal from here to here, and we're back to being fully constrained. We'll deactivate, and look at that, we've automatically generated our part. And can we flatten it? Indeed we can, again with our 1/1000th of an inch flat face that doesn't hardly show up anywhere, right? So that is way within the tolerances of a sheet metal part. We just need a little straight section somewhere. So now that we can bend and unbend it, we can also add features to our sheet metal part, right? We'll do something like some circles. In fact, maybe we'll do a little tab here where I can make this, we'll give this a vertical relation right from here to this edge. Oops, I'm totally wrong though. A vertical actually needs to be coincident, right? So there we go. And we'll give that something like 1 inch is fine. And then I can define this vertically, right? Something like 1.25. And this is very important because I think in other platforms, even with the sheet metal, you can do a straight through cut. Let's go with, a sheet metal cut, or I'm going to say through all. And you can see that we have two sort of arcs here, and that's because it has adjusted the cut for the curvature of the sheet metal. So it's not like you have a straight through cut, like a straight through, extruded cut. You actually have a cut that stays with the profile of the sheet metal, which would reflect this being cut in the flat before it was bent. I think that's a really cool feature. You don't get that with other platforms, and I think it's a cool way to deal with it. So let's do a mirror feature now. Right, so you can mirror stuff in sheet metal. We'll mirror across, and I have to define my plane to my feature here. We'll mirror across this plane, and whoops, looks like my view's stuck there, but we'll define our feature there. You can see the preview. If I say OK, there we go, and this does flatten out and reflect a nice cut pattern. So again, let's bend that back. So there we have some nice features, and I can even mirror that one more time because that would be more realistic of what my axis panel looks like, right? It has those two kind of half circles cut out of it that will hold it onto the side of my water heater. So here's a little sheet metal thing, and if you're wondering, what my water heater axis panel looks like, that's probably an alright depiction of it. So you can cut things, and you can mirror things, and it looks like the cuts update nicely. Maybe we'll want to add a rounded corner, and you can easily do that on a sheet metal part, just like you would add a fillet. And I can do that on, say, these 4 outer corners. That's especially particularly useful for making sure that there's no sharp edges, and you can make sure that things can be deburred properly, right? So there's my rounded corners. You can specify the radius, and we'll apply and close. And there we have now rounded corners. So there's a number of features that you can use on something like this. And the contour feature allows us to really go with a custom or rounded sheet metal part. Now, was there anything else that I was going to cover? I believe there was. Yes, I recall. There was one more thing, and that was going to be a new part entirely. So let's save this so you can download it if you'd like. And let's go with another part. So we're going to choose a new sheet metal part. And let's say that I want to sketch out something very round. Right, so I'll create an arc. We can add in a horizontal relation here. We'll grab in a line. There we go with a vertical constraint. This is again just because I want to use contour on this. Make it a thou this time, right? It's still insignificant, 10 times larger than our last one, but insignificant. Let's go with a 6-inch radius, right? Maybe a long bent sheet metal part, and I'll grab my end of my straight, and we'll make that 0.01, right? So 10 thou away. And we'll deactivate, we'll go with contour, we'll make this to a depth of something like 12 inches. And it didn't like that, so we'll go to edit, make sure that it's not just a thickness issue, which it's not. Let's edit that again, and I figured that we would be tangent here. So maybe I'll make this 1/2 inch. No. So instead, let's get rid of this vertical relation and define this with tangency. There we go. And now if I try to do a contour, there we go. So it looks like it just comes down to a tangent relation between things in the sketch. I'm glad that happened. I'll leave that in so that if you ever troubleshoot something, you can also see how I fixed that, and that was with a tangent relation. So we've got our global bend radius here, which is not applicable in this case. I'll say OK. Maybe I want to close that up again with something like, 10 thou. So we've got a real nice gap there that should be easy to weld closed if that's what your goal is to do. From here, let's say I want to cut out a tab in this long feature. Well, it's difficult to define things bent up like that. You can. It's just a little bit tricky. So one way to do this is to go with an unbend, which is different than pulling out the flat pattern, right? I choose a fixed face, which in this case will be my very, very small face. We'll select all bends and we unflattened it. Or if you have multiple bends, you can choose what bends you want to and not want to unbend. But now we've got a flat piece, right? It looks like our blank. And this unbend has been added to the history tree. So now I can sketch on this face, and maybe I can define, a little bit of a cutout here. So I can choose, a coincident relation between these lines. And I'm not really sketching for design intent as much as speed here, so ignore my lack of design intent as I define this, but maybe 1 inch by 1 inch by 2 inches, and then I deactivate. I can do a sheet metal cut through all, right? And now I've done what I wanted to do. And now I can rebend. And when I rebend, I simply select all bends. And I've been able to update this so I can add features easily in the flat state and bend it back. And now in my history tree, as part of making the part, I have unbends and rebends. This was never, of course, intended to be a part of the manufacturing process or a reflection on how they would actually make it, but a way that you can unbend and rebend things to help you out. You can also do linear and circular patterns of features, like what I've done here. And there's a number of things like dimples that I haven't covered, but hopefully this is enough to get you moving on sheet metal if you're interested in doing some sheet metal design with Alibre. I hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.